Hi there. In this video, I'm going to talk about specifically about execution calculation and gameplay effect in gameplay effects. And it's a direct continuation of the first video we did where we implement some attributes in Blueprint. And the goal of this video is to show what the plugin does and provides to make it possible to implement exec classes directly in Blueprint. Those classes are implementable in Blueprint, but they are lacking very important API and helpers exposed to Blueprint to be able to actually base the calculation logic purely in Blueprint. So that's the goal of this video. And yeah, let's go. The project there is a direct continuation follow-up of the first video where we implement an attribute set with a health attribute, max health, regenerate, and damage. Damage is a meta attribute that's handled by post gameplay effect execute, where we subtract the incoming damage, the current health from the minus the incoming damage. The effect itself, damage effect itself, is using the damage attribute as an output, and it's applying some damage when I click on the target. So instead of using modifiers, I'm going to implement an execution class. I can do so using executions, calculation class, and creating a new blueprint based on the correct parent class. So using this little plus button, it's going to make it easier to create the blueprint. It's a child of gameplay effect execution calculation, so coming from the engine. And then the first thing we need to do is to implement the execute method. Next thing we need to ensure is to set up the relevant attributes to capture. It's going to be all the attributes the calculation class will need, namely to capture the attribute value. So in this case, I'm going to need damage and health. And both will be on the target. Damage can be snapshot and health. If you look at and type blueprint attributes, within the exec-calc category, you'll see all the API exposed by the blueprint to help in implementing the logic for calculation. So we have a few methods, and all take these input parameters from the execute method. So since we're in a function, I'm going to use the fact that they're local variables. So yeah. What we will do in this calculation is pretty basic. Just want to show how to capture the attribute value and output modifiers. So yeah, let's start. I'm going to start with a sequence. First step will be to capture some attributes. The capture attribute magnitude. We are going to get the value of the damage attribute and the health attribute. We will store them locally, and then we will be able to base the logic. We need to fill up the correct parameters, and there we need to pass in the relevant attributes to capture we set in the class default, and you can get them from this class and get the variable itself. What you do, okay, let's tidy up a bit. I'm going to promote the value to a local variable, similarly to what we did in the previous video with implementation of the post gameplay effect execute. Base damage. I'm going to call it base damage. This one, health. Target health. Okay. Usually what I do is first step, I do the setup for the method. So I'm getting all the attribute values I will need. I might use this method to get the tags that are present on both the source and target. If I want to, I don't know, tweak the logic based on certain tags, if they're present or not. Yeah. Second step is usually the calculation itself. And the third one is where I output the modifiers. But let's start with the calculation. What could we do? We're just going, since I don't have yet attributes like attack power or armor, but I think I will go through that next. We'll just set some standard, calculation and with predefined value. So I'm just going to set up a new variable that is going to be base damage minus maybe multiplied. So let's say we're going to have an attack power attribute at some point. It's going to be divided by 100. And let's promote it for a local variable right now and set its value to something like, I don't know, 200. And this is going to be the output of our damage. So I'm going to create a new variable and call it outgoing damage. Of course, the logic for calculation can be a lot more complex than that, but yeah, just to illustrate the concept. So now we capture the base damage, the target health. We're only using the base damage actually. But now I want to show how you actually output modifiers for your calculation. And the way you do that is using output modifier. And you make sure that the first one will need to make the struct for the execution output. You specify the attribute you want to output. So in this case, it's going to be damage. Remember that we had in the gameplay effect modifiers on damage, and it's handled by the post gameplay effect execute. So we want to do the same and output damage as a modifier. And there we need to specify the magnitude for the outgoing damage. If you need to output more attributes, more modifiers, you can do so by chaining the calls. So the first one will need to make the initial struct, but then you can use the return value to chain the call. And let's say, I don't know, I want to add one max health every time I'm doing a damage. I could do so like so. And you would make sure that you pass in as the return value for the function the execution output that you build with this. Okay, let's try. The effect is already configured correctly. So if I set up a debug breakpoint, when I try to apply the effect, this execution gets triggered, and we get the actual values out of the captured attribute. Something is missing right there. I see that the magnitude for damage is at 0 because I forgot something important, is to actually set the modifiers. And there you'll get all the capture attributes you have in your execution. So that's why we set them up just before. And there I'm going to start like before. In the modifiers we had in the previous video, I was just outputting 10 damage. And if I try to check again, we get the 10 damage as an incoming damage. Okay. And if I remove the breakpoint, do I have some health removed? Nope. Maybe it's because of the attribute source. Nope. No, that wasn't that. It's because I forgot to pass in the output modifier. So this one was empty, so no modifiers at all. And now it should work a bit better. So we remove 10 every time we apply the effect. Outgoing damage, is it base damage, attack power? If I change to 200, base damage of 10, okay. Let's debug it out. Here we have a value of 20. Yeah, I see. We output, instead of 10, we output 20, but I forgot that in the execution, the post gameplay effect execute where we handle the damage meta attribute, I'm actually dividing it by 2. So let's set it back to just minus local damage. And now we remove 20. If I change the attack power, we should damage it a lot lower, with a lot lower value. So yeah, that's pretty much all there is to it to be able to implement gameplay effect execution class in Blueprint. Maybe it could be good to introduce new attributes to have something more useful and to base our logic from. Instead of adding attributes right there, I'm just going to create a new one. It's quite quick. I'm going to call it stats set. And in there, I'm just going to create quickly an attack power attribute and maybe an armor attribute. And both we will be able to use them in the calculation. They don't need to be clamped. So yeah, gameplay attribute data is more than enough. Attack power will be replicated. Yes. And armor. We need to make sure that the character and its ability system component does have the new set since it's another one. And if you check in game with show debug ability system, we have the new attributes. Let's set it to some sensitive defaults. Attack power will start at 100 and armor at 50, but it really depends to what we will do in the execution itself. Let's scale it. Instead of now using a predefined attack power, we will capture the new attribute. Attack power, promote to local variable, attack power. Something to not forget is to update the captures. We need there, let's set it back to source. Source or target for the damage doesn't actually matter. But for attack power and armor, it does. Attack power it will be on source, and the armor will be on target. And let's capture the armor attribute. Okay. We can quickly check. We're getting the values. 150. I'm getting 150 there. So 100 is the attack power for this character, and armor is 50 is the armor for this character. Now let's update our logic. Attack power needs to be okay. I was getting a hard time getting the local variables back. Attack power right there. If I redo the math expression, it would detect the local variable is there. I didn't need to add it as a pin, but that's the same same deal. And now for the armor, could do some kind of logic like this. I'm going to reduce the incoming damage based on the armor the target has. So we need outgoing damage there. Outgoing damage multiply by 1 minus armor divided by 100, something like that. I actually already did something, so that's why I know a bit of the logic. But yeah, we will need to, for armor mitigation, we need the damage to apply and base our logic based on this. So I came up with this formula, which I'm going to reuse. And this one will set the outgoing damage based on the armor of the target. So it's going to reduce a bit based on the armor value. And damage we don't need another modifier. So let's set some breakpoints to see if our logic is correct. Okay, the first one. Then we have outgoing damage, which is at 0, so something's wrong. Attack power is at 100, base damage is at 0, so we have something with the damage. Why? I think I did a mistake there. I changed to source, and now it's not capturing the damage anymore. Yep. If I set it back to target, then okay. That wasn't just the variable wasn't set yet. Attack power at 100. And actually the calculation was good to go. So I need to make sure that I check the return value there, because when I hit the breakpoint, the variable is not set just yet. So yep, this one is at 10, and when we set, it's going to be mitigated by the armor and divided by 2. So let's remove the breakpoints and play with by tweaking the values for the attributes. So as you can see, we remove 5 health for each execution of the effect. If we increase the armor value and set it to 100, it would effectively negate all the damage to the character, since yeah, it's at 100. The logic is implemented in a way that the armor is um, handled like a percentage. But if I change it to 10, we should do a lot more damage. I think it would be 9. Yes, 9 damage. And if you go into negative value, it would be kind of like armor penetration. And set it to minus 100, it would double the damage we do. So yeah, that's really nice to have this possibility to iterate super quickly based on the calculation like this, to be able to add new attributes this quick for attack power and armor, and base our calculation there. Yeah, it's kind of a really nice and enjoyable workflow. And to close it up, I just want to show how you would implement an additional modifier, because you can output multiple one. You don't need to adjust just the damage. So for instance, I could, for all execution of the effect and execution class, I could maybe, I don't know, add some armor to the important to the target. And for this case, I'm just going to add 1 or maybe 10 to the character. And to have an easier time to check the attributes, I'm going to use the command to see them. So we have start at minus 100. Let's clear the attributes because I want to see the health too. So we have all the attributes, and the health is regens. Armor is at minus 100. When I apply some damage, it's going to change the health attribute, but also output some modifier to the armor. And now we have 0 armor. So the calculation itself would just pass in the damage as is. So 10 damage at 15, 5. But if I click enough, they go to 90, for instance, let the regen effect go up again. It should apply just 1 damage now. And yes, that's the idea. And now that we have increased the armor more than 100, we don't get any damage anymore. But that could be also handled by clamping the value to a maximum amount, like, I don't know, 95 or 100. That really depends on your game design. So yeah, that's pretty much it. How you would handle and implement execution class in Blueprint. I hope you liked the video. It was helpful to you. And yeah, see you next time. Thanks for watching.